Hello, everyone. My name is Chao. I'm a learning scientist from the Concord Consortium. And my team has been working on AI education for many years. It's always fascinating for me to see so many ways that AI intersect with education. We have heard using AI to support established learning goals and also new learning goals. Today, we have heard about using AI to support proven classroom practices and also some experimental pedagogies. And my work is very distinct from all of that. We focus very much on teaching about AI, how AI works, and how to create AI. So if you have a laptop with you, you may want to bring it up. We have a network here, MIT guest. We have a live demo. You can join and follow along together. So the tool that I'm going to show is called Markov chain tool, and it's built for middle school and high school learners to explore generative AI. And this is kind of part of the larger research project that we have been working on with Carnegie Mellon University, North Carolina State University. It's generally funded by the National Science Foundation. We wanted to bring AI topics into the school. So there's many different ways you can do that. You can create a standalone AI courses. You can put an AI unit into existing CS courses. You can also create after-school programs. But we chose to embed AI topics into core curriculums like math class, English language class, or social studies class. That's because that's where all the students are. And we also wanted to mobilize all the teachers in the school to participate to promote AI literacy. So that's our approach. And also, when you put it into math class or English class or social study class, it really makes it very clear about the interdisciplinarity of AI. Yes, it's not just a CS topic. It's actually require a whole village of people who understand computer science, who understand math, and who understand the domain and the problem we're trying to solve to build together. So when you put it into an English class, the English teacher really taking the reign of explaining how it works. And the last thing that we wanted to do is using AI topic as a driver to enhance the students' learning of their core subjects. Especially for English class, and I know a lot of English teachers are kind of caught in the crossfire of the whole thing. Some schools are entirely ban those large language model usage, and some schools are very open to it. But a lot of teachers that we have talked to, they all are worried about students losing their own voice when they're doing their own writings and speaking by excessive use of AI. So they wanted students to really see through the AI, what's behind the scenes, what's under the hood. So let's open it up and to see what's really the intelligence. It's there. So it's very surprising how welcoming the English teacher for our research project to go into their school. Tomorrow we will have another session where I'm going to talk about our work in the math classroom. We really have a set of curriculum modules that we bring together into the class, into the school, and we recruit a team of teachers to promote AI literacy together with us. So the English curriculum module actually has 3 parts. The first part, we ask students to write something on their own, and then the same writing prompt, we're going to give it to AI, and AI will also write. And then they're going to shuffle all of these writings and try to detect which one is written by one of their classmates and which one is written by AI, and start to look for some characteristics of AI-generated text. And then we move on to the Markov chain activity to really open up the black box to see what might be behind. And of course, we can't really explain how ChatGPT or any large language model works, because that's way too complicated. But we have found a more classical statistical model called Markov chain, which can convey some fundamental concepts behind generative AI. Then the last activity builds on their understanding of Markov chain to extrapolate some concepts that's behind more fancier models. And I will provide the link to the curriculum module at the very end, so you can all take a look at that. So Markov chain is really a model we use a lot to model sequence data. What is sequence data? Thinking about where you have been recently, maybe home, school, office, and home again, school, office. So if you're tracking your own locations, that's a sequence data. And if you capture the pattern in that data, right, your transition between these locations, and you can pretty much predict where you're going to be next. And also your drinking beverage habits, coffee, tea, water again, and water again, right? And weather or music. Music can be represented as a sequence data as a Markov chain model. So you can use your imagination to think about what kind of state that you have in mind, and then transition from state 1 to state 2 and to state 3. So this can be represented as this bubble and arrow diagram. And then you can see this larger bubble, state 1, means that state 1 happened more frequently than state 2 and state 3. And then also the arrow between state 1 and state 2 are a little bit thicker than the other arrows. That means the transition between state 1 and state 2 also happen more frequently. So once you have this model, so you may have some data that you use to be represented by a Markov chain, you can start to generate things. So say that you start with state 1, maybe you start from home. You have 3 possible places to go. You can still stay home, still being state 1, or you may go to school or may go to office. There's 3 possibilities. And then the probability of each transition is really determined by the pattern in your data. And then the actual transition happens, and you're at state 2. And when you're at state 2, again, you have 2 possibilities to go next. You can go back to state 1 or go back to state 3. So now you see a little bit of the generated sequence, state 1, state 2, blah, 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 and ongoing. So let's apply this idea to text generation. And here's the tiny URL you can try with me. It's tinyurl.com/markupdemo1. Okay. tinyurl.com markupdemo1. So once you open, you'll see something like this. I'll zoom in a little bit to show you. So now here I already have a sentence here. This will be kind of input text you use to build a model. So we're gonna use the let's say use the drawing one. And then you can click on this T. This will open a text input box down here. And I will start to type in my input text. So once you type in, you will see this big bubble pop up. That's the first state, which is the word mine. And then it transitioned to the word name, just as our sentence is Jimmy, and my cat name is Alfredo. Okay, so are you seeing something like this on your screen? And you can move things around to kind of spread things out a little bit. So you can see the transition between these words and punctuations. And then and you can also click on these bubbles to examine them. For example, the word mine, the incoming transition is from the word and the outgoing transition is to cats and name, right? So there's 2 possible words to follow that. So now we already have our model. We can start to to make some sentences with it. Let's start with the word mine. So you can choose your starting state. And let's write a sentence that's about 10 words long. You can put 10 here in the max length. And then use the space as your delimiter. And for now, we're just going to step through it to see how it's generated, the sentence. So click on step. You say start with mine and 2 possibilities. And then go on the actual transition to mine. My name is Jimmy. And my cat's name is Jimmy. So it's varied a little bit, right? Not exactly the same as the original sentences. And you can keep generating. Let's generate another one. See if it's exactly the same. My name is Jimmy, and my name is Jimmy. That's exactly the same. But if you keep doing this, it won't be exactly the same every time. And the student will see why, things like ChatGPT will give you slightly different things every time because it's predicting based on probability model. And once you finish the generation, let's see, finish this one. My cat's name is Jamie, and my name is, this is Alfredo. Okay, so it's flipped our name. So you can also click on each output and to see this is how the sentence were produced. And really behind any fancy model is a mathematical model, a complex mathematical model that pulling all of these states and transitions and predicting the next word using the existing context. And in this model, the existing context is very simple. It's really just a previous word. So we in the English class, we ask students a little bit more about, okay, so what if we not just use one word, one of the previous word as the context, but use a longer chain as the context? Would your model produce more human-like or more realistic writing, but lose a little bit of variety, or the opposite? So there's a lot of questions we can let the student to experiment with, to answer for themselves, and thinking about how this may connect it to their own writing as a human writer, right? When they write, how do they choose words? And they can also do something interesting here. For instance, I can click open the word mine and then change it to your. And then your model suddenly will produce different sentences based on this modification. You can also change the probability of each transition. You say, okay, I want the probability to go into the word name to be higher, and then going to the word cat to be lower. So once you do that, you see the arrow size get a little bit different. Now, if you let it to generate to multiple outputs, you can actually see the differences. So that's the Markov chain demo, and we did do. Okay, so let me just show you a quick longer text. So you can copy a longer text to it and then produce a much bigger web like this, and then let it to generate more complex writing. And so the input was an explanation of what how text generation work, and then let's see what it says. It started to say something that kind of makes sense, right? So so we did a pilot study last year with 44 ninth grader students, and they think a lot about, in a classroom, the English teacher would ask a student to think a lot about word choices, and they start representing simple sentences with Markov chain, and then move on to more complex data set to generate the text. And they would discuss the limitation of their models. And they also try something we call bigram, trigram, or tetragram model, which I mentioned earlier. You can make the state of each, make 2 words into each state, or 3 words into each state, which will make your model work a little bit better. And I'm going to fly through these. You can read the paper. We have some positive results from the pilot study. Students do feel like they have get better at explaining how generative AI works. And we also have performance-based knowledge assessment and showing that they have learned a lot from before and after the curriculum module. And especially interesting results is girls actually appear to learn a little bit more than male students. That's very, we're very happy about this results because we know girls in general, they are underrepresented in computer science classrooms. So if you go to a computer science classroom, they're not even there, but this is an English class. So they're there and they learn at least as equally well as their male peer. Okay. I know we're running out of time, so I want to thank everyone for your time.